Hi, I'm Alina, and this is my final project presentation for Math 152. I chose to do the cord cutting survey. Let's start out on the right sheet. Sorry about that. So I had nearly 300 survey responses to my data set. I think it came out to 297. Since those first couple rows were questions, but on my right I have my random elements. I believe I chose N as 31, and I have the ages corresponding to those. And although I didn't utilize the data from question 3, which is how many paid streaming services do you subscribe to, I thought it was still very interesting to have incorporated, and these are their responses. So let's move on to our summary sheet. So I have my ages ranging from 21, which is our min, and ranging all the way to 80, which is our max. If we look at our standardized data, we stay within 2 standard deviations from the mean with all of our ages, with the furthest being a negative 1.7. But we have 1.4 on the positive end from the mean, which isn't as far as negative 1.7. So that was something that was really interesting for the central limit theorem. Just went over the min and max. So we have 9 classes and our class width is 7. And this is our frequency table that has our frequencies, our classes, and displays our class width of ages. And as we go and take a look at our 5-number summary plus sum, we have a mean of 53.1. So if we take a look at our ages and our standardized data that correlate with these ages, we have 2 that are within 0 standard deviations of that mean. So we have a mode of 72. 72 occurs 4 times out of this data set. That is the age that occurs the most. Excuse me. We have our mid-range at age 80, our range 59. Or, sorry, I did not mean to say mid-range at age 80. We have our range at 59, variance 353.2, standard deviation of 18.8, and COB of 35.4. So we went over our min already. Our first quartile, or 25th percentile, is 34. So that will exist between here. That is a quarter of our data set. Median is 59. Median is a biased measure of center. Since I chose 31, 59 is right in the middle. Q3, so our 75th percentile is 66. So this is our top 25%, and this is the lower 75. Max 80, interquartile range is 32, lower fence is negative 14, and upper is 114. I had no outliers. And if we take a look at our histogram, we have a left skew occurring, but we start out really strong, it seems, visually. At first, we kind of get that skew going, and then we shoot back up with our histogram when we reach getting around age 50 or so, I would say. And our mean exists somewhere around here with that 53.1. And if we will move on to our hypothesis test for the proportion, My question was, using your sample test the claim that the majority, which is more than 50% of these respondents, are over the age of 50. So I've got my ages and my count. Anyone that's under the age 50, you get a 0. And anyone that is 50 and above, we get a 1. I just summed these at the bottom, which we had 21 out of 31, which is my p hat expressed as a decimal, 21 out of 31. N for the number of samples that I have, which is that x over n, the 31. My claim p as a decimal is, since we're testing at 50%, it is 0.5. My alpha or significance level is 0.05, and we are testing above 50 or more than 50%. The claim we're testing is that these respondents are more than 50% of these respondents are over the age of 50. And this is our null hypothesis, which is equals 0.5. And our alternative is we're testing that the majority are greater than 0.5. So we're testing this p hat. We come out to a test statistic, oh my goodness, of 1.9757 or 1.976 if we're rounding. Critical values, we have 1.6449 or 1.645. And our p-value is 0.0241, and we're testing at a 0.05. So since this p-value is less than our significance that we are testing at, I came to the conclusion that at a 0.05 level of significance, I would reject the null hypothesis. There's sufficient evidence at the 0.05 significance level to support the claim that the majority, which is more than 50% of these respondents, are over the age of 50. I did a confidence interval for the mean. My question was, using your sample, estimate the average age of a survey respondent with a 99% confidence interval. I have my ages listed on column A, my point estimate mean, which is 53.13, very similar to what we saw on my summary page. Just took one of those decimal places out. Standard deviation 18.79, and the confidence level we're at is 99%. So out of these 31, which is N samples, the lower age, if we're rounding to a whole number, is 44 or 43.85, and the upper age is 62.41 or 62. With this information of that upper and lower age, we have the conclusion of I am 99% confident the mean or average age of all 31 individuals on my list for the subscription survey is between 43.85 or 44 and 62.41 years of age or 62. I tried to be thorough and kind of fast. I didn't want to exceed the time limit that Mr. Blevins highly suggested. But I will say that this class has been a journey. And although it took a lot of time and patience to wrap my head around some certain things, I've learned how we can really apply a lot of these concepts to like our everyday lives. And it also kind of highlights how important it is to understand truthful statistics and testing, and just how crucial it is to be honest about these stats that we are always being shown. So now we have this information to go forward in the future and utilize for ourselves when it comes to decisions or taking in information and questioning, well, how'd you test this? That's kind of how that's where I'm at the end of the semester. But Thank you so much, and I hope you all had a great semester.